All right, so get this. Microsoft says they've cracked it. A working quantum computer, something they've been at for 17 years.
Hmm.
And get this, it uses totally different tech than those big names like Google and IBM.
17 years is a long time. They must be pretty excited to finally unveil this.
Yeah, it's a pretty bold claim for sure.
Yeah.
There's definitely buzz around it.
It's causing a stir, for sure. The science world's kind of going crazy for it. But, quantum computing,
Right.
it's early days still.
Yeah, it is. Okay, so for anyone just joining us, what are we even talking about? Quantum computing that uses
Yeah.
the almost magical rules of quantum mechanics to do things our everyday computers just can't handle.
Yeah. Think of it this way. A normal computer, it uses bits that are like a light switch, right? It's either on or off, 1 or 0.
Right.
But a quantum computer uses these things called qubits, and they're more like a dimmer switch. They can be 1, 0, or both at the same time.
Whoa.
This is what we call superposition.
Okay.
And it lets these computers process just insane amounts of information all at the same time.
So that means they could solve problems in a couple days that would take our best computers today millions of years.
Yeah. You're talking potential breakthroughs in everything, medicine, materials, science, cracking codes that we thought were unbreakable.
Whoa. Okay, so to make things even more interesting, Microsoft's approach. It's unique. They're using these things called topological qubits,
Right.
which are built on these elusive particles called Majorana particles.
These are a bit of a head scratcher even for scientists.
Yeah.
It's like imagine a coin that can be heads, tails, or both at the same time.
Whoa.
It's pretty mind-bending,
Yeah.
but that both at the same time thing, that's what makes them so special.
Okay.
And potentially perfect for building these crazy powerful quantum computers.
And that both at the same time thing, the superposition, it's way more stable in these Majorana particles than in the superconducting qubits everyone else is using.
Right? That stability is the key. If you want to scale up to millions of qubits, which you need for a truly powerful quantum computer. And that's what Microsoft's aiming for.
A million.
Yeah.
They want to go from the 8 qubits they got on their current Majorana 1 chip
Right.
to a million. If they can pull that off,
It'd be huge.
game changer.
Total game changer.
Imagine being able to model complex molecules, design new materials, crack the toughest encryption.
Yeah, but let's not get carried away just yet. There's a new report in Nature questioning if Microsoft has really achieved what they're claiming.
Really?
There's definitely healthy skepticism in the scientific community about this. Stephen Simon, a physicist at Oxford, said, "Would I bet my life on it? No, but it looks pretty good."
So is this all just hype, or are we really on the edge of a quantum revolution? We've got a ton of reports and articles here. Some are super optimistic, others are a little more cautious.
Yeah.
We're going to help you break it all down, separate fact from fiction, understand what this could really mean for the future.
One of the big questions is whether these Majorana quasi-particles actually behave as predicted.
Right.
That's crucial to the whole thing working.
And even if they do scaling up from 8 qubits to a million, that's a massive leap.
Yeah, absolutely. But here's where things get really interesting. Microsoft isn't going it alone. They've partnered up with DARPA, the U.S. military's research arm.
Oh, wow. So this isn't just a tech race now. This has
Right.
national security implications.
Big time.
They're hoping to have a working prototype in just a few years, potentially jumping ahead of everyone else.
But they're not the only ones in the game.
Right. Google's got their Sycamore processor, IBM's got Eagle and Condor, and there's even this trapped ion tech some other companies are working on.
It's a multi-front battle for the future of computing.
It's a whole showdown.
Absolutely. It really is. It's like we're watching a bunch of different approaches unfold, and it's not just about who gets to a million qubits first. It's also about which technology ends up being the most reliable, the one that can actually go the distance.
It's almost like a horse race where each horse has its own strengths and weaknesses. You got the thoroughbred that's super fast, but can it keep up that pace for the long haul?
Yeah, exactly. You need a Clydesdale in there for the stamina, and then there's always that dark horse that nobody saw coming. The one that could surprise everyone.
Oh, yeah, for sure. So let's talk about the money involved in all of this, because it's not just about a science. It's about the resources needed to actually make this technology work on a large scale.
Right.
And that's where things get really interesting. Microsoft has invested a whopping $80 billion in these AI-focused data centers,
Wow.
which are essential for both AI and quantum computing.
These data centers are basically the engine rooms of this whole tech revolution. They provide the massive processing power needed to run these incredibly complex systems.
So we're talking about massive server farms, huge amounts of energy, but capable of crunching data at speeds that were unimaginable just a few years ago.
Exactly.
But there's been chatter about Microsoft maybe pumping the brakes a bit on some of these data center projects.
Yeah, there have been reports of them pausing construction on some centers and even letting some lease agreements expire.
Which is kind of strange considering they just announced that $80 billion investment.
Right. It's definitely raising eyebrows.
Yeah, so some analysts are saying this points to maybe a weaker demand for AI than everyone was expecting, while others think it's just a strategic adjustment.
It's hard to say for sure at this point.
Yeah, it's a bit of a puzzle. One article we read suggested that Microsoft might be seeing early signs of an oversupply situation. Like maybe they overestimated the immediate demand for AI-driven services and now they're adjusting their plans.
That's certainly a possibility. The AI field is moving so fast that it's incredibly difficult to predict future demand, even for a giant like Microsoft.
So what does this mean for the average person listening right now? Is it time to reconsider any investments in AI or is this just a bump of the road?
It's tough to say. It really depends on your personal risk tolerance, I think. If you believe in the long-term potential of AI, then this might be a good buying opportunity.
Okay.
But if you're more risk-averse, it might be wise to wait and see how things play out.
That's the thing about all of this. It's constantly changing, and frankly, nobody really knows what's going to happen next. Even the experts are having trouble keeping up.
Right. It's a wild ride.
Yeah, so it's important to stay informed, do your own research, and be prepared for the unexpected.
Absolutely. Don't just take our word for it. Look at the data, read different perspectives, and form your own
So
conclusions.
let's get back to Microsoft and their quantum quest, because there's another piece of this puzzle we haven't talked about yet. They're not just relying on these topological qubits. They're also using this new type of material called a towconductor.
Oh, yeah, those are fascinating. They're kind of like a hybrid between a semiconductor and a superconductor, and they're really important for creating a stable environment for those Majoria-based qubits to work properly.
So think of it like this: semiconductors are what we use in our current electronics, right?
Yeah.
And superconductors, they can conduct electricity with zero resistance. So when you combine the two, you get this material with unique properties that are perfect for working with those finicky Majoria particles.
Exactly. It's really cutting-edge stuff, and it could give Microsoft a significant edge if they can get it to work reliably.
The whole point of these topological qubits is that they're much less prone to errors than the superconducting qubits being used by others.
Yeah, that resistance to errors, what they call fault tolerance, is like the holy grail of quantum computing. A fault-tolerant quantum computer would be able to correct errors as they happen, making it much more reliable and scalable.
So you're talking about a quantum computer that could run for hours, even days, is what crashing.
Right. Imagine that.
That's pretty incredible.
It's the kind of stability and reliability that we need to really unlock the potential of this technology.
It's still very early days, though. It's like we're watching the Wright brothers take their first flight.
Exactly. We know it's going to change the world, but we have no idea what that future will look like.
All right, so we've talked about the tech, the financial side, and the competition, but let's not forget about the potential applications of all this, because that's where things get really interesting.
Yeah, it's not just about building these fancy computers. It's about what we can actually do with them.
We've mentioned drug discovery, materials, science, cryptography, but it goes way beyond that.
Imagine using quantum computers to design entirely new forms of energy or to simulate the human brain with incredible precision.
Or to create artificial intelligence that surpasses human capabilities in almost every way.
It's both exciting and a little terrifying to think about.
Oh, absolutely. One article we came across even talked about how Microsoft had to make changes to its Windows 11 File Explorer because of privacy concerns in the EU.
Really?
Yeah, it just shows that we're already starting to bump up against regulations that weren't designed for this kind of technology.
And as these quantum computers become more powerful, those concerns are only going to grow.
Right, we need to start thinking about how to protect ourselves from data breaches, surveillance, even the development of autonomous weapon systems.
It's a lot to consider.
It is, but that's why it's important to have these conversations and to stay informed about what's happening in this field.
Absolutely.
So let's zoom out for a second and look at the big picture. What are the key takeaways from our deep dive into Microsoft's quantum leap?
Well, I think one of the main things is that Microsoft is clearly a major player in this field.
Right.
Their approach with the topological qubits and conductors is unique and potentially game-changing, but it's still very early days, and there are a lot of challenges ahead.
And the race for quantum supremacy is not just a technological one.
Right. It's also a geopolitical and financial race with huge investments coming from governments and companies all over the world.
And we can't forget about the ethical and societal implications of all of this. This technology has the potential to completely reshape our world, both for good and for bad. So what happens next? Well, like we've been saying, it's crucial to stay informed, keep up with the latest developments, read articles from different perspectives, and don't be afraid to ask questions.
Right, because the future of quantum computing is going to be shaped by all of us.
It's not just a story about Microsoft, of Google, or IBM. It's a story about humanity.
And it's a story that's just beginning. It's like we're standing at the edge of this completely new world, and we have no idea what's waiting for us on the other side.
Yeah, it's like we're on the verge of something huge, but we don't know if it's going to be amazing or terrifying or maybe a little bit of both.
I think it's safe to say it'll be all of the above. It's like, think back to when the internet first started becoming a thing.
Right.
Nobody could have predicted how it would change our lives, how it would connect us, and also create all these new problems.
Yeah. And now imagine that, but on a much larger scale, because quantum computing, it has the potential to disrupt pretty much every aspect of society.
Exactly. We're talking about changes to medicine, finance, transportation, communication, you name it, quantum computing could have a hand in it.
And one area where it could have a huge impact is AI.
Oh, absolutely. We've already seen AI make incredible progress, but with quantum computing, those advances could happen even faster.
We could be talking about AI that can, like, design new drugs, cure diseases, manage entire economies.
Even create art and music that's as good as anything made by humans.
Whoa, yeah. It's kind of mind-blowing.
It is, but it's not all going to be positive. There are some serious concerns about the downsides of all this.
Right, like privacy and security.
Exactly. One article we read talked about how Microsoft had to tweak its Windows 11 File Explorer because of EU privacy concerns.
Really?
Yeah, it just goes to show that our current laws and regulations aren't really equipped to deal with this quantum future.
And as these computers get more powerful, the potential for misuse is only going to increase.
Right, we need to start thinking now about how to prevent things like data breaches, surveillance, the development of autonomous weapons.
A lot to think about.
It is, but that's why we need to have these conversations to make sure we're prepared for what's coming.
Okay, so let's step back for a second. What are the key takeaways from our deep dive into Microsoft's quantum leap?
Well, first of all, I think it's clear that Microsoft is a serious contender in the quantum computing race.
Right.
Their approach with the topological qubits and the topping conductors, it's unique and it could be a game changer, but it's still unproven and there's a lot of work to be done.
And second, this race for quantum supremacy, it's not just about the technology.
Right. It's about geopolitics, it's about money, it's about who controls the future of computing.
And finally, we can't forget about the ethical and societal implications of all of this. Quantum computing has the potential to change everything.
For better or worse.
So what happens next?
Well, I think the most important thing is to stay informed, keep up with the latest developments, read different perspectives, don't be afraid to ask questions.
Because the future of quantum computing, it's not just up to the scientists and the engineers.
It's up to all of us.
This isn't just a story about Microsoft or Google or IBM.
It's a story about humanity.
And it's a story that's just beginning. So keep exploring, keep learning, and keep asking questions. Because the more we understand about quantum computing, the better equipped we'll be to navigate the challenges and opportunities that lie ahead.
This has been The Deep Dive. Until next time, keep questioning, keep learning, and keep diving deep.